Bayes theorem is simply when like there are multiple events going on, but there's a single event. Like there's a single last event, let's call it A event. There are multiple ways that let me just write that there are some events, and like these events of B are like the ways to go and to do a certain event. Okay, so first B1 event will happen and then A can happen. B2 and then A can happen. Like it's these are some ways, and these are events of B. These are dependent with A. And also one more thing is that wow, I have just discovered one thing. When I'm touching my finger to stylus, then my finger is also able to write because of inductance. Anyways, let's go back to the mathematics from physics. So here B1, B1, B2, B3, all these events are mutually exclusive and exhaustive events. Meaning when B1 event will be happening, then B2 cannot happen. If Bn event is happening, then Bn minus n or any other event cannot happen. So uh, to find out the probability that event A has happened through B1 way, then we solve it using this formula. Probability of B1 into probability of event A has happened, given that it has happened through B1. Probability of event B1 and probability of event A has probability of event A given that A has happened, or the probability of event B2, the probability of event A given that event B2 is happened, probability of event Bn, probability of event A given that probability Bn happened. So this is somewhat uh, how Bayes theorem looks like. We will also discuss some examples more so that we are more clear about the theorem. So there is a question. I have a previous year question. Let me write it.
Hello, sir. Can you hear me now, sir?
Yes.
Yes, sir. I have completed my homework, sir. Oh.
Sorry.
I have completed my homework, sir. That time I was not unable to unmute my mic, sir.
Okay. Great.
Yes, sir. Just now I saw your voice message, sir, but I completed my homework, sir.
Okay. A bolt is drawn from the product. If the drawn bolt is found to be bolts. Bolt is found to be defective. Now this is a given event A as per our formula. Then find the probability of that it is manufactured by second machine. This is the formula. This is the question. Okay. So let's read the question. In the boards factory, there are three machines manufacturing 25%, 35%, 40% of the total boards. So the event is the ultimate event is manufacturing boards. Of the total output of 5%, 4%, or 2% are defective boards, respectively, from the machine 1, 2, 3. Okay. A bolt is drawn from the product. Okay. If the drawn bolt is found to be defective, now this is the given event. As per our formula, it is A. We have to find out that what is the probability that the defective bolt that we have withdrawn is manufactured by second machine. So first, uh, like there are three machines. The probability of choosing a machine is 25%. Why 25%? Because 25% of the time it is the machine making a bolt, 35% and 40%. This is simply how much of the total bolts they produce in the factory. And 5% defective bolts, 4% defective bolts, and 2% defective bolts. 25, 30, 60, 60, 40, 100% of the bolts are manufactured by these three machines only. Out of those, 5% machine bolts are defective. Okay. 5% of bolts that are manufactured by the respective machines. Okay. So a bolt is withdrawn. Okay. So what is this? Now if there are like total bolts, if you are taking any bolt, so what are the chances that the bolt is from the first machine? Probability that drawn bolt is manufactured via machine 1. So how many total bolts are manufactured here? 100, let's say 100. Okay. How many bolts, favorable bolts are there manufactured by 1? 25%. We are ignoring percent. Oh, also we can write percentages also. Then percentage cancels. 25 by 100 becomes 1 by 4. Right? Probability of this also 35 by 100, 40%. Or we can keep this in percent also by writing 25% just. Okay, so now we have understood one thing, that the probability of choosing machine 1, machine 2, machine 3 will be equal to the number of percentage of boards that they are manufacturing. Is that clear?
Yes, sir.
So we can say the probability of choosing machine is 25%, 35%, and 40%. So this is somewhat like the event B1, event B2, event B3, because that's not the ultimate event. Ultimate event here is the manufacturing a defective bolt. Okay. We have to find that that machine 2 is used, and it has used to make a defective bolt, which is given to us. Okay, so we will write probability of choosing machine 2, and that it has given a defective bolt via machine 2, divided by probability of choosing machine 1, or into, now in the denominator we consider all total possible cases. So probability of manufacturing defective bolt via machine 2. Sorry, machine 1. We are discussing about machine 1 this time. Probability of choosing machine 2. Probability of manufacturing a defective bolt via machine 2. Probability of choosing machine 3 into probability of choosing, manufacturing a defective bolt via machine 3. So this is the formula. Okay. Now, we may also understand that these are the 5% of the bolts made by machine 1, and 5% of the bolts are defective. They are defective. Okay, so probability of defective bolts we are respective machines are these 5%, 4%, 2%. We are calling event A as manufacturer of defective bolt. This is the event A, defective bolt. Event B1 is, or event second is basically choosing the machine. Okay, then. So can you tell me what is the probability of choosing second machine? It is there on your screen. 35%? Yes or no? Probability of choosing the second machine is 35%. Second column, second machine, right? Now, probability of making a defective bolt via second machine is 4%. Okay, so this has become, let's okay, let's now substitute the values from our conclusion. Okay, probability of choosing second machine while manufacturing a defective bolt. Now the probability of choosing the second machine is 35%. Oh, multiplied with probability of manufacturing a defective bolt. Okay, manufacturing a defective bolt via second machine. Second machine, this is 4%. Similarly, probability of choosing the first machine, 25%. Probability of manufacturing a defective bolt via first machine, 5%. Plus probability of choosing second machine, 35%. Multiplied with probability of making a defective bolt via second machine, 4%. Probability of choosing third machine, 40%. Multiplied with probability of making a defective bolt via third machine, 2%. And now we are going to cancel all the percentage, because there are 2% in every percentage is getting multiplied twice in every term. It just got cancelled. And now we'll solve. We can also divide the numerator and denominator by 5. Yes, 5, 35 by 5 becomes 7. 5 by 5 becomes 1. 35 by 5 becomes 7. 40 by 5 becomes 8. 7 into 4, 28, divided by 25 plus 28 plus 16. The answer comes out as 28 divided by 25, 25, 53. Okay, 53 plus 16, 69. That is our answer. 28 by 69, basically. Though that's not important. Important is whether you are able to understand how I have written this formula and applied this. Is that clear, everyone?
Yes, sir.
Completely clear. Also, do make sure to watch the recording of previous class so that you will be able to better understand what is based here.
Yes, sir.
Yes. So this was the previous year question of NDA. Today we will be finishing our chapter. So there is a small topic left. Let's discuss that. First, let's discuss what is a variable called. But before that, there's an important question. A man is known to speak truths. Truths का सामना 3 out of 4 times. He throws a dice and reports it as a 6. Find the probability that it is actually a 6. Okay. So here, what can happen? What can happen is this: whether a person can speak truth or he can lie. And a dice can be 6 or cannot be a 6. Some other 5, 4, 3, 2, 1. So basically our event is happening or not happening. Okay. So what is the ultimate? The ultimate is to reporting a 6. Okay. He has reported a 6, that is for sure. So if he has reported it as a 6, it is a given event A. Okay. If it is truth, then the dice is 6. Dice outcome has a 6. So I should write it. Dice has the 6. Or if he is lying, then dice do not have a 6. Are you able to understand? These are two events, V1 and V2. And the event that has happened for sure, the event that has happened for sure is A, that he has reported dice as 6. Okay. Now what we have to find out? That find the probability that it is actually a 6. It will be actually a 6 when the guy is speaking the truth. What is the probability of him speaking the truth, it is three or four times. So if he speaks 3 out of 4 times the truth, then 1 out of 4 times he speaks a lie. There's the probability of him lying. The probability of even B1 is 3/4. Probability of even B2 is 1/4. What do we have to find out? We have to find out that he is actually speaking the truth. So probability of even B1, given that A has happened, given that event A has happened, okay, then probability of event B1, probability of speaking a reporting a 6, given that he is speaking truth, or we'll consider all the scenarios in the denominator, plus probability of him lying, reporting 6 while lying. Okay. So is this clear till now? How have I written and how have I assumed that this event is A, or these events are B1 and B2, and how dice being 6 or not 6 is dependent on speaking the truth or lying, because he has already said whatever he has to say. Is that clear, everyone?
Yes, sir.
Okay. So probability of him speaking the truth, 3/4, into probability of reporting a 6 while he is saying the truth is 1/6. Why? What is the probability of getting a 6 is 1/6. Probability of getting a 6 is 1/6. Probability of getting not a 6 is 5/6. So there's the probability of getting a 6. Now probability of this is the same probability of him speaking the truth, getting a 6 and reporting a 6. If he lies, then probability of his lying is 1/4. And if he lied, then reporting as the probability of reporting a 6 is, now see, you have to understand this is the probability of reporting a 6, given that he is lying. Now, see, you have to understand one thing, that a person will report 6 and he can lie only when the outcome is not 6. Then only he will be lying. Otherwise, he will be speaking truth. So that outcome will not be favorable for us. Here we are discussing about that he will lie and he will report a 6. So he will lie and report a 6 only when it is not actually 6. So that is why it should not be 6. So what other elements are there? 1, 2, 3, 4, 5. There are 5 favorable outcomes here and total are 6. So the probability of this event becomes 5/6. Is that clear how it is 5/6? He is reporting 6, but he is lying. It means it is the outcome of the dice is other than 6. Other than how many cases are left then? 5. That's why the number of favorable cases are here are 5. Is that clear, everyone?
Yes, sir.
Okay, so in the denominator part here we can see 4 into 6 is everywhere in every term, so we'll just cancel it. Now what is left? 3 into 1, 3, 3 into 1, 3, plus 5 into 1, 5. 3/8 is our answer. Okay, Bayes' theorem is important. There are high chances that you will get a question on Bayes theorem. Random variable. So basically, assume that you have tossed two coins. So the sample space will, sorry, the sample space will be this: head tails, or tail head, or tail tail. Now let's assume there is a function x. Okay, there is a real valued function x which assigns to each outcome every sample space. This function is applicable to a unique real number. So the output of the real number, the output of the function is real number. It gives some real number with respect to every sample point, every outcome, you can say, right? In tossing of two coins, the sample space is this. So let x this time be a function where it denotes the number of heads in tossing of two coins. So how many heads are there? Two. How many heads are there? One. How many heads are there? One. How many heads are there? Zero. So that is the real valued function value for these all. And also this R represents that which outcome is this, like the numbering of outcome, the first or the second or the third, like this. Okay, so what is written? It x denotes a number of heads in tossing of two coins. Then there can be no head, one head, or both heads. So total sample space is covered by our function. Here x is a random variable such that x hh is 2, x th is 1. Basically, it means that x has varied. It is a variable, so it keeps changing. Like for a sample point, it is 2, some another sample point, it is 1. For some other sample point, it is 0. Clearly, the domain of x is the sample space, and range of x is 0, 1, and 2. Here, the domain of R, the range is 0, 1, or 2 because of the sample space. Because the number of heads can only be 0 or 1 or 2. So this is the range. The domain also it is only derived by the sample space. Okay, you will be more clear after reading this. So this is called as the probability distribution. So here we are considering a function which will give us the number of heads in the particular outcome. So when we will write the probability of x is equals to 0, means that the probability of getting no head is 1 by 4. Tt is the particular sample point where we will be getting no heads. Probability of x is equals to 1 means that the number of head will be 0. So it will be done when head tail or tail head are the favorable sample points. So there are two favorable sample points out of 4. So the probability becomes 1 by 2. Probability of getting two heads. X is equals to 2 means probability of getting two heads, two number of heads. This can only happen in one sample point out of 4. So that's why the probability is 1 by 4. Now the probability distribution of x is given by when x is equals to 0 means these are simply the number of heads, and these are the probability of happening so. probability of X. Probability of getting 0 head while tossing 2 coins, then the probability of getting 0 head is 1/4. For probability of getting 1 head while tossing 2 coins is half. Probability of getting 2 heads, probability of getting 1 head is 1/2. Probability of getting 2 heads while tossing 2 coins is 1/2. Simply, just representational changes are no concept changes. Okay, so the sum of probability density function is 1 always. Statement questions can be made from this statement. Is that clear, everyone? Are there any doubts? Are there any doubts? Is that clear, everyone? Should I repeat?
Yes, sir.
Yeah. Okay, then let's move ahead with discussion of its application. Binomial theorem for probability distribution. In this particular binomial theorem, we'll find out like the number of successes, how many number of successes can be there. And this will be particularly useful when there will be multiple number of repetitions happening of any certain event. Like if we are tossing a coin for multiple times, then to find out the probability of getting, let's say, head 1 time, 2 times, 0 time, 5 time, then this particular theorem is going to be of use and convenience, because will not be able to solve and write all the sample space and then analyze how many number of favorable outcomes are there, how many total number of possible outcomes are there. So it would be of use for us. Now what is this? First let's write probability of getting r number of successes. R number of successes means uh, getting some favorable event R number of times in sample space. So we'll write NCR. N is basically the number of repetitions or the number of tries. P denotes the probability of one success. Probability of getting one success. Raised to power R into Q. Q is basically nothing but what the probability of not getting any success. So most of the times Q is 1 minus P raised to power n minus of R. Let me write it again here that n belongs to number of trials. P is representing probability of getting a success. Single success, I say. And Q is the probability of getting single failure in pursuit of our desire. And also as like they are just the opposite of other. So P plus Q is equals to 1. Any doubts, anyone till now? It will be more clear when I tell you an example. Are there any doubts in understanding P, Q, and R?
No, sir.
Okay. So the next question is, we are tossing a coin 6 times. Okay, and then we have to find out the probability of getting head 5 times. So let's go to the question. Six times probability of getting 5 heads. So instead of thinking about tossing the coin 6 times, let's discuss about probability of getting a head when in single try. We'll first discuss about the success. This is basically the probability of success. Probability of failure. Failure will be when there will be tail in single try. What is the probability of getting a head when we toss a single coin? Anyone? Probability of getting a head. If you have a coin, right, and you toss it, single coin, single time, what is the probability of getting a head? It is very simple. Just say it if it's there in your mind. Just say it. Just need to open your mouth. What is the probability of getting a head when you toss a coin? Don't read the question. Don't read that what is written on the slide. Just use your brain.
50%, sir.
Yes, 50%. It's half. Same for getting tails also it is half. So PQ is half and half. N is number of trials are 6. Okay. Now how many successes do we want? Is 5. So probability for 5 successes. What success means to us? Of getting head is a success. So N C R into P raised to power R is what? 5 into Q raised to power N minus R. Okay. 6C5 is 6 factorial, basically 6 only, but 6 minus 5 factorial is 1. 5 factorial into 1 raised to power 5 into 1 raised to power 6 minus 5 is 1. So 6 factorial gets cancelled by 5 factorial by 6. 6 into 1 raised to power 2 raised to power 5, 1 by 2. 2 cancels 6 by 3. It becomes 3 by 2 raised to power 2. I should write 3 raised to power 2 raised to power 5, which is 32. Answer. 3 by 32 is our answer. Clear? Is that clear, everyone?
Yes, sir.
Yes. Now please tell me how many total number of elements will be there in the sample space when we will toss the coin 6 times. So first head can come, then on the second place, let's recall the PNC. What we are doing, we are tossing a coin 6 times, so 6 results will be there. Okay. How many choices for every result for every tossing of a coin? 2. 2. And we are noting down them all. So they are all dependent events. The tossing of every individual coin is a dependent event. So fundamental principle of counting. Total number of elements in sample space, total number of possible outcomes can be 2 raised to power 6, which is 64 events, which we cannot possibly write in the limited time period that is there in the exam. So binomial theorem rescued us from this adversity. Okay. So let's, what is there in the other slides? Yes. If probability of success of an event A is a random experiment, sorry, if probability of success of an event A in a random experiment is P, the probability of its failure is Q, which means that P plus Q is equals to 1. Experiment is being repeated independently n times. Independently n times. Then probability of exactly R success out of n is NCR P raised to power R into Q raised to power n minus R. Probability of at least one success can be written as probability 1 minus probability of no success. Okay, probability of at least two success. So at least two success means two success or more than two success goes on and on. Otherwise, we can also write probability of getting no success minus probability of getting one success. Khatam. So by these two calculations only, we'll be able to find out, and we'll ignore solving for all other probability of successes for how long we don't know, right? So this is an important thing to consider. And also one more thing, is sometimes given to you that it is a distribution, so its mean will be, and what will be its how should I say, standard deviation. You will be getting to know what is standard deviation, what is mean in statistics, but now just understand. And standard deviation and variance. What I am writing here is very important for you to understand. Mean will be simply n into p. You are already aware about what is n, what is p. Standard deviation will be n into p into q whole square, and it is definitely n p q. Okay, so this is really important. Please heed to the formula. Okay. Is that clear? Ki what is, basically you have to cram this formula, if I say in direct words. And you have to understand what is n, what is p, and what is q. Is that clear what is n, p, q, and what is I have written, I meant to write here. Is that clear or no?
Yes, sir.
Okay, let's solve some questions then. From a box of containing 20 tickets of a value from 1 to 20, 4 tickets are drawn one by one. Okay, so there's a box of 20 tickets. Basically, there are numbers 1 to 20 having these numbers are there on 20 tickets. So basically, they are numbers. 4 tickets are drawn one by one. Now, these event of taking a ticket. Okay. One after each draw, like if you have drawn one ticket, then the ticket is replaced. Okay, so no, it's not happening after one by one. It's happening that once you have taken any take it out, then after seeing it, you will place it back. So withdrawing a ticket and then placing it back, and once again withdrawing a ticket and then placing it back. So all the events are same and independent. Why independent? Because they are not dependent on each other, because the tickets are being getting replaced. So nothing changes after you have taken a ticket out, seen the number, and then have replaced the number. Okay. So there is nothing changes much. So there are independent events. Okay. So how many repetitions are, basically these are same events happening 4 times. How many repetitions are there? 4. The probability that the largest value of the ticket drawn is 15. Okay. So what you want is you want to get 15 only. This is the largest. And you should, and the other 3 should be 15 or less than 15. Can be 15 or less than 15. So instead, if you find the probability of uh getting at most as 15, so it will be better for you find out, if you find out probability of getting 1 minus probability of getting 16 or 17 or 18, 19 or 20. Isn't that will be a favorable thing for you to find out, right? Hello everyone, hello. First, understand one thing, that there is a box and we are withdrawing one ticket and replacing it back, and we are repeating it 4 times. So it is like the repetition of the same event 4 times, because it is not affecting the next event. What we are doing is that we are taking a ticket and then placing it back. So it does not affect the next event, the next withdrawal of the ticket. So that is independent events. On independent events, we can apply what? Binomial distribution of probability. Okay, so let's try to use the space. This is a box. What is the probability of getting? We are discussing about a single trial, because we have get to know that these all are independent events and getting repeated multiple times. How many times? 4 times. We are first discussing about the single trial. What is the probability of getting the what is the probability of getting 15 or at most 15? So it is somewhat similar like of getting 16, or probability of getting 20, uh, probability of getting 16, 17, plus probability of getting 18, plus probability of getting 19, plus probability of getting 20. And if we sum them all and will subtract it from 1, so that is the probability of getting at most 15. So 1 minus probability of getting 16 is 1 by 20. Getting 17 is also 1 by 20, 1 by 20, 1 by 20. Because only favorable outcome is 1 and total possible outcome is 20. So this is 1 minus 4 by 20, which is 1 minus 1 by 5, which is 4 by 5. The probability of one success, this is a single success, which is P, is 4 by 5. Is that clear, everyone?
Yes, sir.
Okay. So,
Yes, sir.
yes. I guess we are, Probability of 16, 17, 18, 19, and 20. How many? 1, 2, 3, 4, 5. So 1 by 20, 1 by 20 plus 1 by 20. So this becomes 5 by 20, which is 1 by 4. 4 minus 1, 3 by 4. 3 by 4 is the probability of one success. Okay. And instead of that, you can also use a simple understanding of yours. Let me use that only. At most 15 means you can get 1 to 15 all numbers. How many favorable outcomes? How many total outcomes are there? 20. How many favorable outcomes? 15. This is also how you can also find out the probability of one success. 3 by 4. Is that clear?
Yes, sir.
Probability of one failure, 1 minus P, 1 minus 3 by 4, 4 minus 3, 1 by 4. Okay, nice. So we have everything. N is equals to 4, P is equals to 3 by 4, Q is equals to 1 by 4. What is R? What is R? At most 15. So 15 has to be the largest. So if has to be the largest, then it should occur only once. Out of 4 repetitions, 15 can also come out as one time. Is that clear or not?
Yes, sir.
Okay. So required probability will be 4C of 1, 3 raised to power 4 raised to power 4, 1 into 1 by 4 into 4 minus 1, that is 3. We'll solve it. So what is 4? 3 by 4 to 1 by 4 cubed. So basically, what we were solving for was the probability that the largest value of tickets drawn is 50. And first we have solved for that one event, and then we have proceeded further. Clear?
Yes, sir.
Yes. The class timing is over, so I'll also provide the solution of this particular question in the group and some notes will be also sent in the group. Okay, the chapter is over. We will discuss the previous year questions yesterday.